Okay, everybody, here is 7.2. We're going to continue on about solving systems of equations. Just as an FYI, this is very algebra intensive, so if you do not like algebra, you are not going to like this. Sorry about that. Um, yeah, that's just the way it is. So, yeah, that's just the way it is. So if you do not like algebra, you're not going to like this, but suffer through it. It'll be fine. Okay, so here we go. This is called the substitution method, and we actually encountered this method before when we did the problems involving distance, rate, and time with the boats going in opposite directions, or, and we'd had to figure out how long it took. We basically use substitution. So we've seen this method before, but we didn't really give it a name. But I remember I told you guys that this is something that we'll encounter later, and I remember saying that this is a method called substitution. So basically what you're going to be doing is you're going to select one of the variables, you're going to solve one of the equations for that variable, you're going to take that expression for that variable and replace it in the other equation, solve for that one, and then replace it back. Okay? So you are basically substituting and then substituting again. All right? So lots of algebra. If you love algebra or you like the math stuff, then this is for you. So hopefully this will be right up your alley, okay? I have the following. Y equals negative 4x plus 8, and y is equal to x plus 7. All right, so what we're going to do is we are going to solve one of these in terms of y. So let's say we have this y is equal to negative 4x plus 8, okay? And y is equal to x plus 7. All right, notice that for systems of equations, the variable is the same for both equations. And what I mean is that the x that in this first equation is the same x in the second equation. And more importantly for us in this case, the y for the first equation is the same as the y in the second equation. Okay, so the variables are the same for both equations. And we're going to use that to our advantage. Notice that here it says y is equal to x plus 8, right? This y is the same as this y. These two y's are the same. This y is the same as this y. These two y's are the same. So I'm going to take what this y represents, which is x plus 7, and I'm going to replace it into here, right? I'm going to substitute that value, and that's where the name comes from. Substitute that value into here, right? So notice I get x plus 7 is equal to negative 4x plus 8. And this is what we want, okay? The rule for systems of equation is this. Number of equations has to equal the number of variables. If we have more variables than we have equations, we cannot solve it. Okay, so for a system of equations, look, we have two equations and two variables, x and y. Okay, two equations and two variables, and they have to be different equations. They can't be the same equation in different form. So two different equations, two different variables, we can solve this. All right, if we had three variables, like if there's a y and an x and a z, but only these two equations, there's no way we can solve this. All right, so what we're doing is we're essentially trying to squeeze both of these two equations into one equation with only one variable, and that's what we get here. So notice we have one equation with only one variable, and that this is just kind of an amalgam or a mixture of both of these, right? We replace this y with this x plus 7. So we have x plus 7 on this side, we have negative 4x plus 8 on this side, and notice all we have is x's. That's what we want. Okay, we have one equation, we have one variable. Can we solve this? Yes, according to this, yes. We want the same number of equations as we do variables. All right, so how are we going to solve this? Well, you should know how to solve this. This is going to look really simple. We're going to add 4x to both sides because I'm going to move all my x's over to the left, or to the left side, sorry. plus 4x, and we get 5x minus, or plus 7, sorry, plus 7 is equal to 8. Then I'm going to subtract 7 from both sides. Isolating the variable, this is going to be 5x is equal to 1. And then I'm going to divide both sides by 5 to finally get the variable by itself. X is going to equal to 1/5, or 0.2. Okay, 0.2. So now we have the value of x. What do we do with that? Well, now we're going to take this value of x and we're going to plug it in to this equation. We can actually plug it into either one of these. We could plug it into this one if we wanted to, but one of these is going to make things a lot easier. And notice that this one is going to make things easier, okay? So we have y is equal to x plus 7, but we know that x is equal to 0.2, so y is going to be equal to 0.2 plus 7, or 7.2, or 7 1/5. Okay, whichever one you like. Decimal is probably easier. So y is going to equal 7 1/5. Okay. So do we have a solution? Yeah. The solution is x is equal to 0.2, y is equal to 7 1/5, or 7.2. Okay. Now, did we have to do this way? No. We substituted for y. Could we have substituted for x? Yes, we could have. Y is equal to negative 4x plus 8, and then we have y is equal to x plus 7. Now, I'm going to solve this equation in terms of x. So I want, or in terms of y, so I want to say x is equal to, right? Minus 7, y minus 7 is equal to x. So now I have a value of x. I can take this value and plug it into here, right there. Okay? So I get y equals negative 4 times the quantity. Instead of x, we're going to put y minus 7. Everywhere I see x, I'm going to put y minus 7 plus 8. And if I work this out, I get y is equal to negative 4y plus 28 plus 8. And then we're going to work this a little bit more. Negative 4y plus 36. And then I want to solve for y, so I need to put all the y's on one side. I'm going to move them to the left. So plus 4y plus 4y. And that's going to be 5y is equal to 36. And if I divide by 5, this should give me a value of y. And what value do I get? Well, I get 7 1/5, or 7.2. So I get the same result, except that last time we figured out x first, this time we're getting y first. So I get y is equal to 7.2. Then I can plug this into any of the equations that we want to. I could plug it into here. I could plug it into here. Or I could even plug it into here. One of these is going to make things a lot easier, guys. And it's going to be this last one, right? So I'm going to plug it into this last one. Y is equal to 7.2. So I get 7.2 minus 7 is equal to x. So from here, I'm just plugging it into there. And then 7.2 minus 7, that's just going to be 0.2 is equal to x. And notice that that is what we got the first time, okay? So we can do it both ways. You can plug in for whatever you want to, but sometimes it is easier to solve for one of the variables. So do the thing that makes it easier. What are we looking for? We are looking for a situation where y is equal to something. Then yeah, use that, or x is equal to something. So in this case, we have y is equal to something. It makes it a lot easier. Okay? Could we have plugged this value of y into this equation? Yeah, we could have. We would have gotten the same thing, right? Just on opposite sides. Hopefully that makes sense. you want to look at ways to make this problem easier. All right, so let's do a couple more problems. Again, like I told you, lots and lots and lots of algebra. Here we go. 3y plus 2x is equal to 4. Negative 6x plus y is equal to negative 7. And right away, something catches my eye, and that is going to be the fact that this y is by itself. So what I am going to do is I'm going to rearrange this equation because I can get y is equal to something. All right? So we have negative 6x plus y is equal to negative 7. I'm going to add 6x to both sides plus 6x, and I get y is equal to 6x minus 7. All right, so this is my equation that I want to use. I'm going to take that and move it over here, insert over there. So this is what we have. Everywhere I see y, I'm going to replace it with 6x minus 7. So 3 times y, but instead of y, I'm going to put 6x minus 7 plus 2x is equal to 4. And notice again, I have one equation here with one unknown. Can I solve this? Yes, I should be able to figure out what x is equal to. I'm going to use distributive property, 18x minus 21 plus 2x is equal to 4. 18x plus 2x is 20x minus 21 is equal to 4. And then I'm going to add 21 to both sides. And I get 20x, remember these cancel out, is equal to 25. Again, lots of algebra. If you like algebra or it's relaxing to you, you're going to love this, okay? 20x is equal to 25. How do I solve for x? I'm going to divide by 20, divide by 20. I get x is equal to 25 over 20, which comes out to 1.25. 1.25. So x is equal to 1.25. Yay. All right. What do I do with that? I'm going to take this and plug this into one of my original equations. Now, again, I have this equation to plug it into. I have this equation to plug it into. But I also have this new equation that I wrote. Right? Remember, this is just the first equation rearranged. So I am going to plug that into here. Why? Because this already says y equals something with x in it. I know what x is, so that'll give me the exact value of y right away. I won't need to rearrange anything, right? So this is y is equal to 6x, 6 times 1.25. I'm going to replace x with 1.25 minus 7, right? Or that is y is equal to 6 times 1.25 is 7.5 minus 7, or y is equal to 0.5. So I have x is equal to 1.25, y is equal to 0.5, and that is my answer. And if you want, you could actually express this as an ordered pair, 1.25 comma 0.5, because if you graphed both of these lines, these 2 points would intersect at 1.25, 0.5. Okay? All right. I hope this makes sense. Let's try another one. We're just going to keep doing examples, okay? All right. Let's look at this one. Let's look at this one, sorry. This one, okay? Which one should I go for? Well, look, this one is already solved for y. Y is equal to 2x. So yeah, that's the one I'm going to use. That's the one I'm going to use, right? I'm going to take this value and plug it into here. I'm going to plug that into there. So this is what I get. 7x minus y, but instead of y, what am I going to put? I'm going to put 2x is equal to 15. Okay, 7x minus 2x is 5x is equal to 15. And if I divide by both sides by 5, I get x is equal to 3. So now I know what x is equal to. What do? I'm going to plug it into some place where I can figure out y. And again, I could plug it into here, or I could plug it into here. But I'm definitely going to use the second one because this will give me my value of y if I know what x is. Why? Because it says y equals. So I'm going to say y is equal to 2 times x, but x is equal to 3. So that's going to be 2 times 3, or y is equal to 6. So x is equal to 3, y is equal to 6. Or again, if I wanted to write this as an ordered pair, 3, 6, right? X and y. Hopefully that makes sense. Let's move on to the last example. In this case, boy, I'm looking, none of these gives me a good choice for x or y. Okay? None of these gives me a good choice for x or y. Both are pretty complicated. So what I am going to do is I'm just going to pick one. Doesn't matter which one I pick, I'm just going to pick one. Okay? So the way I'm going to do this, just because the numbers here are smaller, right? I'm going to start with that one. I'm going to solve this one for x. So solve for x. Okay? Sorry, I keep hitting the wrong button on this stupid thing. Okay, so I get 3 is equal to 3x minus y, or 9y. I'm going to solve for x. Should be an x. Okay, solve for x. So I'm going to add 9y to both sides. And there's no reason why I solve for x. I just, for some reason, it just appealed to me. It just looked like it would be easier. I don't know why. Okay, it doesn't really make a difference. You can solve for, I could have solved for y here, but I'm going to solve for x here. Okay, so I get 9y plus 3 is equal to 3x, right? And if I divide both sides by 3, I get the following. 9 over 3y plus 3 over 3 is equal to x. This is kind of like when we did converting from standard form to slope-intercept form, right? Or 3y plus 1 is equal to x. Okay? 3y plus 1 is equal to x. So now I know what x is equal to. I'm going to plug this into the second equation. That was my first equation. I'm going to plug it into the second equation. So this is going to be 6y plus 8 times x, but I know that x is equal to 3y plus 1, so I'm going to put that in there for x. 3y plus 1 is equal to 28. Then I'm going to distribute 6y plus 24y plus 8 is equal to 28. And notice I only have y's in this one equation. I can definitely solve it. All right, 6y plus 24y is 30y plus 8 is equal to 28. Okay, and then I'm going to subtract 8 from both sides, minus 8, minus 8. These cancel out, and I get 30y is equal to 20. If I divide by 30, I get y is equal to 20 over 30, which is equal to 2/3. Now I could write this as a decimal, but in this case, writing it as a decimal will be a little tough. Why? Because I get 0.6 repeating, and it is very tough to work with repeating numbers, repeating decimals. So we're just going to leave it as a fraction, okay? Fraction is better. Because repeating. Because repeating, okay? So I know that y is equal to 2/3. What are we going to do with that? Well, we need to solve for x, right? So y is equal to 2/3. Let me write this down here. Y is equal to 2/3. I need to solve for x, so I'm going to take this value and plug it into here, into this equation, because this is already solved for x, right? I know that this is going to give me x. So here we have 3y plus 1 is equal to x. Okay? But I'm going to replace the y with 2/3. 3 times 2 over 3 plus 1 is equal to x. And this one actually comes out pretty nice because these 3's cancel out. and I get 2 plus 1 is equal to x, or x is equal to 3. Okay? So what is my answer? X is equal to 3, y is equal to 2/3, or if I want to write an ordered pair, 3 comma 2/3. All right? Okay, so that's basically it. Again, make sure you end up with one equation with one variable. Solve for the easy variable. Look for places where you have the variable by itself. If you don't have a choice, just solve for whatever. Okay? And sometimes you just have to brute force it. Okay? That is it for today. I know this was a little bit long, but hopefully you stuck in there. And that is it. Make sure you ask questions if you need to. Work on the homework, and I will catch you guys later. Thanks for listening. Bye bye.